Welcome to Bright Ideas TV, and I'm Bob Resselman, and I'm here to present you with the brightest idea of the week for those of you that are interested. And I want to thank our sponsor before we go forward. Our sponsor, it is DevOps.com, where the world meets DevOps. So everybody run out to DevOps.com and give them support. So to start this episode, I have a joke for you, and here comes the joke. The joke is, how does a software developer change a light bulb? And I'm going to ask my guest, Jacob Smith, to answer that. So Jacob, how does a software developer change a light bulb?
I don't think you're going to like my answer because I have a better one than the one you have.
Okay, well, do your answer. There you go. Go ahead.
That's an ops problem.
Oh, okay. Yeah, it's close. Right, it's close, right? Well, my answer is software developers don't change a light bulb. It's a hardware problem, which leads us into this week's guest. And this week's guest is Jacob Smith, who's the Senior Vice President of Packet. And Packet is a very, very interesting company, whereas I got to admit, most of us are like software developers' head. We've never met a light bulb we wanted to change. And we like sitting there with code and, doing our classes and our interfaces and our objects and scaling out on AWS. Jacob is taking a different approach. For him, hardware is the mothership of innovation. And to celebrate Jacob being on the show, I have behind me an NVIDIA GPU chip. So it's very relevant to this discussion. So let me invite Jacob to the show. Jacob Smith, welcome to Bright Ideas TV.
It's great to be here, Bob. Thank you so much.
Did you like my GPU chip behind me?
Yeah, I'll take 100 of them to go. Could you just drop them off?
Yes, in Indonesia.
Yeah, that'd be great.
In Indonesia. I want 100 of them in Indonesia. So I know we're being a little circuitous here about getting the Jacob's bright idea and Packet's bright idea. So why don't we do that now? Jacob Smith, Senior Vice President of Engagement at Packet. What is your bright idea?
My bright idea is pretty simple. It's that hardware is the next innovation layer, okay? Hardware is the thing that is going to transform your business over the next 10 years, whatever you're doing.
Okay, what makes you say that?
Well, it's pretty simple. That thing that's sitting behind you is, what is it? We call it an NVIDIA. We know the brand name. It's a GPU, right?
Right.
But what it is a special bit of silicon. It's basically a customized processor that does something really well. Whether it's inference or training, it happens to be about taking stuff away from a very generic processor, right? The mothership in the Intel world would be a x86, based processor. And it says, no. You know what? I know exactly how to do that thing. I will do that way better and way cheaper. So a GPU is the really early example of what, people have said it's the Moore's Law is dead. Right? They say Moore's Law is dead. And that was the whole thing where, every 2 years or 18 months, we could cram more transistors onto a CPU and essentially double the performance while keeping the cost going down. It was kind of brilliant. But at some point, physics and things get in the way. And so people talk about that like, well, it's dead. Well, what's next? And what's behind you is an example of what's next. Not just like really expensive stuff, but essentially really specialized stuff. And so whenever you start to do something that's really big or really important, which a lot of the things we're doing now in the internet and the world, whether it's like bioinformatics or making cars drive themselves or whatever we're doing, they're really big workloads. There's a lot of data, there's a lot of things to process, and you just can't do it with generic hardware. And so, long story short, the reason why hardware is the next innovation layer is because of all your software that you guys have been writing over the last 10 years to make things like AWS and software portable and deployable around the world in minutes. Well, now it wants to touch on the new kinds of hardware. And I think that embracing that is really the next wave. And so there's a really great opportunity for us to understand it better, for us to be able to get into all the problems. There's a lot of challenges there, and figure out how we're going to take advantage of things like the big chip behind you, but also just a zillion new bits of silicon that are coming out that are really good at doing one thing. And I'll end by giving you one example because I have a finger right here. And I'm sitting on a MacBook Pro. And on a MacBook Pro, there's a little touchpad thing now that you can touch to unlock your computer, to buy stuff online, to do whatever. And essentially, it's a fingerprint reader, right? But it also is fully encrypted and does all these other things. It's a custom processor based on, I believe, an ARM architecture that Apple has licensed and customized to that one very special need, which means it's low power, it's secure, it's doing all these things just for that. And I think we'll see more and more of your MacBook, let alone more and more of your data center, be filled with these specialized, customized bits of hardware.
Wow, that becomes interesting. So it almost, the analogy almost becomes, and correct me if I'm wrong, in the old days, we used to have carburetors, right? We put the carburetor on top of the car, and that
Mm,
served us really well until we've maxed out the capability of the carburetor. And
yep.
somebody said along says, no, 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 no. If you rely on that hardware, car manufacturing is just going to go nowhere fast. So we'll create the fuel injector, and the
Mhm.
fuel injector dramatically, changed the way cars go. Is that a
Yep.
correct analogy?
Yeah, I mean, it's a really simple idea. And when the workloads get big enough, the hardware, you start to design the hardware around the software instead of the software around the hardware. And for the last 10 years in the cloud space, which is where we live and where a lot of us spend a lot of our time, even if, you ask a third grader where the cloud is, they tend not to know where it is, but
Hmm.
it gets them thinking a little bit. We spend a lot of time in the cloud, and that world has been pretty much around doing generic stuff. Oh, I had email over here and I want email over there. I had databases over here. Let's make it easier. But you're starting to see things creep out, that are just so much bigger that either you're spending so much money or so much power, right? Electricity. I mean, it's just not sustainable to, do some of these workloads with generic things that you just don't have enough electricity in the world, let alone enough workload and all that. So,
Well, that's interesting. So I imagine you're pretty close then to the chip designers and people who are thinking about how to make chips cool. Is-
um, we talk to them a lot. We're really good friends with them, and I tell you why. I mean, this is a little indulgent, but it's because so first of all, we care about hardware. We're hardware nerds. I mean, I'm not an electrical engineer, but when I was a music major at Carnegie Mellon, I spent most of my time over with the Meckies and the Eckies, like seeing what they were doing, because I'm just really interested in it. Um, so we spend a lot of time with our friends at Intel, at AMD, at ARM, and the various licensees there. And there's just like new ones every day, right? Obviously, NVIDIA,
yeah.
GraphCore. You get the list goes on and on. Um, what they're really good at is inventing things.
Hmm.
Right? They're doing hard engineering. Like we're not doing rocket science at my company. What we're really doing is helping to connect that hardware
Hmm.
innovation
Hmm.
with the buyer. And the buyer is no longer, it used to be a couple of years ago, 5 years ago, 10 years ago. For that, the buyer was, a integrator, like a manufacturer who's going to go take that and build you a PC, or
Hmm.
take that and build you a thing.
Right.
Well, now the real customer is actually the software developer,
Right.
or that person's software. And so they drive the demand in a way, but it's really hard for a big company focused on R&D like Intel, which is a great partner of ours, to know the customer. I'm not sure when's the last time you kind of saw a commercial for Intel Inside, but it's been a while, right?
Right.
And so it's just not the connection that people have anymore, and yet it's becoming this new source of opportunity. Um, there's one thing that's kind of made that happen, bigger than the rest, which is that the cloud, revolution over the last 10 years has really abstracted people away from the hardware.
Hmm.
Instead of, well, here's a virtual machine, which is great. It's easy. Thank you so much. Then we're starting to go up the stack and say, well, let's get this as a service. Let's get this up here. Okay, maybe a serverless function. We keep abstracting away from the hardware. It's impressive and powerful stuff. And it's actually a big part of how people should deploy. But you don't ever really get to go down there and go like, what's that? How could I
Right.
use that differently? What's
Right.
under the hood of that car?
Right.
I wonder if I took that carburetor out and started to use this thing, injected the fuel over here.
Right.
And that's a huge opportunity for companies that want to really lead in their space and be technology like empowered, not just abstracted.
Right. That becomes interesting because what I like what you're saying about that. We'll create a piece of software and we'll wrap the hardware around it. And that hardware might not even exist yet. And so what that leads me to start thinking about is in artificial intelligence, particularly, where we
Sure.
start having AI functions that are very robust and very comprehensive, and that we have to start creating hardware to handle that logical service. It becomes a logical service, and this is will manifest it in the hardware. Do you see that as something on the horizon?
Oh, yeah. I mean, absolutely. I see that going, you see that all the time. We talked about we're talking about a company called Apple who happens to design hardware around software, right?
Right.
Or at least they're like so tightly coupled, it's indistinguishable.
Right.
That's the whole value proposition, not just for their design focus, but also so their battery life lasts longer, right?
Right.
So that they can recognize your face, even if you're wearing glasses today and not glasses tomorrow. I
Right.
mean, I think you see that these things start to work really closely together
Right.
instead of sort of someone makes the hardware and then you make software.
Right.
Now I think you'll see, at least for some customers, maybe not all, but some people are going to be like, you know what, I really need more out of that.
Right. That becomes interesting to me when I start. I'm interested in genetics and disease battling stuff. So it becomes interesting if you start thinking about wanting to start affecting particular strands of the DNA with nanotechnology, so that you can say, okay, we really want to go after this, this gene, and we'll actually create a hardware device, a nano hardware device.
That's really good at that, right?
That's really good at it. We'll just push, we'll eat it. We'll literally eat it, and when the device will make it go away. Wow,
I use that example, although I know nothing about medicine like you
right.
do or genetics, but the idea that, a drug company today might be in the really personalized medicine business tomorrow.
Mm-hmm.
They may be saying like, well, my advantage is that I can analyze, Bob, your DNA in, a minute versus a day or
Right.
whatever it is. And I can then turn around and find the right solution for you with more accuracy or less impact or whatever it is. I don't know what it is. But the idea that you would just do that sort of like on generic stuff is antithetical to the way we've seen it happen in the past, which is you start getting things that are really important, really critical. You start designing them holistically.
Mm-hmm.
And I think that's why, it's not currently a really easy thing to do right now. You have to basically be huge in order to say, I want to play in the hardware game.
Right.
And that's kind of why we started our company. And that was our big idea. It was like, we kept seeing, software push its way down the stack. I remember we were having lunch or a beer or something with Alex Polvey, who started CoreOS. And he was just getting started. And I'm like, what are you doing, Alex? And he was like, well, I'm going to write a new operating system. We're like, why? That's crazy. Isn't the operating? We got Linux already. It's already good, right?
Yeah.
It's like, yeah, I think we can do some more things there. And that was really a light bulb for me. That got a light bulb going on, which was like, they're going to go all the way down. Software is not going to be content just to stop at the, where everyone else stopped. A lot of developers, they tend to have a lot of opinions. And
yeah. And they're always right too. Yeah.
They're always right, for sure. Absolutely.
How could I have doubt?
And so maybe it moves from like, I don't want to replace that light bulb to like, I have a better light bulb, let me put mine in,
Yeah, right. Yeah. That becomes really interesting. And but in a way, it's, meet the new boss, same as the old boss. So going back to, reminds me just the days of struggling down on my motherboard CMOS to get my virtual machines to run.
That's right. That's about right. Yeah. Hopefully we're going to do it a little bit better.
Yeah, right.
But those skills will come in handy, let me tell you.
Right. Or go back to go talking to specific memory areas just to open up expanded memory.
Well, that's so funny. We were doing this thing with AMD recently, and they have a new processor. It's EPIC processor or whatever, and it has a particular differentiation around memory channels or whatever it is, right? Something very specific. This is a pretty generic use case, But the difference between having 16 cores in a processor and 24 or 28 actually means that certain software doesn't even know how to take advantage of it. It's like, well, we kind of stop at 16 or 18 or whatever it is, right? And so that's actually one of our core values is like, we don't know all the answers. I'm not going to help you figure out all the ways in which you can take advantage of this. What I can do is give it to you. I can make it available in a way where you can touch it. And you have this cool, NVIDIA behind you right now, this GPU sitting there. But actually, it's pretty hard to get your hands on one.
Yeah.
You'd have to spend thousands of dollars, if not tens, right? You'd have to have a place to put it. You'd have to have it just for you. You'd have to power it. You have to do all those things just so you could play with it.
Right.
That's not the way we work anymore, right?
Yeah.
Now we work like, okay, I'm going to go, touch it, from afar. And so that's really the premise of our business was like, hey, can we bring that experience that a developer could touch, could automate hardware and do it in a way that they were comfortable with, like the cloud. That's the buying experience and the deployment experience, which is like not, hey, let me go talk to IT and get a server in 6 or 8 weeks or hours or whatever. It's like, I'll send an API call and some minutes later, I will have that resource.
Wow.
Every time.
Wow.
Yeah.
That's an amazing future. Guess what? We've come to the end of our time. Well, we just have been so interesting, but I do want to have you back on. Actually, I want to have you back on maybe in a symposium with some other developers who get this. Because it is a different way of thinking now that everything's been abstracted away and we just call somebody to change the light bulb. But I want to thank you for your time. Jacob Smith at Packet. Is there any way people can reach you if they have any questions?
Well, you could always call me, but no one does that anymore. So if you want to reach us, go to packet.net. It's not packet.com or packet.net because we care about that stuff.
Right.
And you can find us on there. I'm usually accessible through one of our lovely support people. So find us if you want to talk about hardware, you want to talk about software, doing them together. I'd love to chat.
Okay, great. Thanks, Jacob. It's been a great session.
Hey, Bob. See you soon.
Okay.